I just want a bag, like an old lady. I'm backwoods smoking, I don't own papers, pass that 808. That shit a dome shaker. Oh, bitch, you know I'm grinding like a pro skater. Baby mama bugging, I'm so quick to hit ignore. Buku bitches in my bed, I got scales all on my floor. I got money on the line, plus I'm clocking that galore. I got bitches kissing bitches, all them bitches go explore. I'm feeling way up, well fuck it, I stay up. Put your bitch on my Snapchat, when I fuck up I make her. She want a chance with me, cause she know I'm a rapper. I give a dick but I never get feelings, cause shawty I know what you after. Okay, they watching me, they watching me, they watching me. They watching me, they watching me, they watching me. They watching me, they watching me, they watching me. They watching me, they watching me, they watching me.
Hello everyone, back for Friday hacking practice, and we're going to continue with the Nightmare course that I've been working on for probably a couple months now. Took a detour earlier this week to work on a bunch of anger specific CTF challenges, and then last stream we went through almost all of the challenges in the symbolic execution section, but this one, Plaid CTF 2019 I Can Count, was not able to resolve that one using anger, so going to keep working on it basically, because I just sort of threw the most standard implementation at it, and it was taking a long time. I didn't bother trying to run it like overnight or anything. Maybe that approach would be fine, or will be fine, if I let it go for a while. But I would like to look through the code and try to think about whether or not there's a way to make this more tractable, I guess. Because I don't really, other than the fact that it wants me to count, oops. I'm trying to see if, I think it gives maybe a random response every time. Yeah, so it gives some random complement because it calls this get complement function, and it wants us to count some amount, I guess. I could certainly try to run that with, you know, Pwn tools. It would be pretty simple to write a script. I guess we can try that, right? Called it Pwn solve rather, instead of oh no, it's from Pwn import everything, I think. Or is it, oh, wow, it's been like a week since I've done this. Let me, real quick. No, I had it right the first time. From Pwn import everything. So yeah, we could just like and so we'll just do, oops, just do that, and then let's do okay, so at some point I'm expecting we'll get an exception from this. I guess I need to put it in like a try catch block. Or is it accept? And we'll just skip whatever that exception is, and we'll try to print whatever we set the last line to. That way I'm not spamming with all the responses, but we'll just loop until the process basically dies. Give it a timeout of 2 seconds. So, I mean, because it's not over the network, that it really should complete basically immediately or fail entirely. So if we give it a timeout, then what do we want to do? I'm trying to think. Oh, and probably print out I as well. Why not? Oops. Really, I want it to give... I guess this is fine, right? So if it times out, we'll keep the last line, because I think Pwn Tools, pwnlib tubes tube.tube. Receive line, timeout, and an empty string is returned. Okay. So let's double check. Okay. Cool. So those both are falsy. So the logic here is we'll do the receive. If it hits the timeout, then we will go into the OR case. So last line will remain whatever it was. And then we'll loop back to the beginning, and the send line will definitely cause an exception because presumably it timed out because the process ended. And let's see. Can we do... number of bytes returns as soon as any quantity of data is available. Just trying to think, like, would it be good to get more than the last line? Let's just go with this for right now. And I'll let it go for a minute, and then I'll kill it, and we'll see if we can. I guess it says correct. Oh, because that's one of the, yeah. Whatever. Let's see. We want to do... segments. Could just say I. So we'll print out I. What? Oh, I meant to say. Okay, so obviously whatever number we need to count to is pretty gigantic. Which I think is part of why the anger process was taking so long. If we are trying to simulate everything, so I think what we want to do is I'm going to go with Okay, I thought it might be printing correct for some other reason, but that's just one of the generic responses. So we want to avoid this total loop situation if possible. I want to know what increment flag looks like. Okay, it does something or other. I can do in Sterling. So I know that this is the failure case, I guess. We are comparing local 26, which I believe is what we are getting to, yeah. And what? Trying to understand this logic right here. So we're calling fgets on presumably EBX from EBX the okay, so instruction relative kind of thing. Well, let me fgets takes the buffer first, and then the size of how much we want to take. So is that 31 characters? And then the stream, I guess this is the address of, yeah, how we get the standard in file pointer. But then what we're doing is we are looking at the first byte. And if it's 0, so I guess if we got an empty string, then we'll come down here and we'll do a string compare. Like we always end up here anyways. So we are checking the last digit. Oh, sorry, this is just 30, and this is 31. I see. So we're checking that the honestly don't know. Like, I see what it's doing, but I don't understand the reasoning, I guess I could say. Where we are looking at the last character in the buffer that we read in, because we get the length, we subtract 1 from it, and then we use that as an index into the buffer. And if that byte is greater than 31, we'll just jump down to the comparison. Otherwise, we are setting it equal to 0. So 31 hex being the digit 1. So if we have a final digit that's like 2 or more, maybe I'm misreading what this comparison is doing. But if we end on a 0 digit, or I guess it's just dividing by 10 in that way. And then we're looking at whatever this string is, which that's going to be rather annoying to calculate. Well, not that annoying, I guess. So what we want to do is say okay, so this string is probably the angle bracket. Well, I like all the different what call them, complement strings. Actually, let's not look for the angle bracket because it's probably not going to show up very well in this. But we should be able to find the 3 puts first. So, are you ready? It's going to be this one. Are you ready? Okay. So EBX minus certain value is that. So EBX minus 1C0B is equal to that. So if we add 1C0B to it, so we'll do question mark plus 1C0B and set, I guess so. So it's 3000. It's going to be what we have in EBX. So then EBX minus plus 48. Did we set a thing in there? Oh, 48 is just we will be setting whatever we need to set for the next number to be input, but we're just doing it as a string for some reason, I guess, to force more complication rather than do numerical comparison, because anger, its symbolic execution process is going to be more tripped up by string compare. And then all the string length stuff. think about that later. Okay, then I think I want to start with get or check flag and see what that looks like. Obviously it's doing a lot of stuff, and maybe this is not the proper exit, but I feel like this is just gonna return, right? Okay, so if we come down here, what are we getting? So taking that string that's at now ESI plus 48 hex, and we are looping 20 times, and then if these numbers are not equal, we'll go through. So we're doing some sort of check, but I think then what we need to do is just run from this point, and we will set ESI to a certain value, and we will set ESI plus 48 to be a symbolic bit vector. We don't know the length of that bit vector, it would seem. But maybe we can just sort of guess at it. Oh, I guess, you know, maximum it's 30 characters long. So we'll just set it to that, and then we'll see symbolically execute to get to this printf. So we'll print that plus this string, which I'm curious at 3000 minus 1C6E is okay. So then it print like the number is the flag. Yeah, that makes sense. Okay, so let's modify our solve, and we won't do an entry state, we'll do an initial state. Or can we say yeah, how do we do the initial state at a certain address? We wanted, we probably did it for like 4. Blank state. That's what we want. Okay. Blank state, and we can set the address. And the address we want to start at is this one. So we'll want to set 40,000, I think. So main options is base adder goes to base. Then this will be base plus A5C. That'll be our starting address. I think we can turn off Vera testing. I don't know what that does still, but it's not what we needed it to be. You know, it might be that part of the reason that, well, I mean, it never finished, right? So we didn't get the couldn't find solution result, but the good exit, am I using the wrong, what are these addresses about? Oh yeah, FA9, if we get to that exit statement. I guess that's fine. And the bad exit is if we get to base plus 0 FAE. Pretty nearby in locations, but it's all good. Okay. Right, yeah, that's fine. Then we still need to say flag is clarify.bvs of 30 times 8 and ESI is going to be equal to $4,300. I don't know if that really helps, but I'm gonna try that. 43,000, I guess, because it seemed to be 3,000 in this baseless situation. Or we can do base plus 3,000, and then we want to say flag or state.memory.store at ESI plus 48. Store the flag there. Then if we found a solution, we'll solve for it. I think that'll be a set of bytes, and we'll just print out that flag value. Okay. Anger vn bin activate. Doesn't like main options. Is it defcamp R100? No. It was 12, maybe TU future. Nope. Tokyo Westerns. No. Maybe it was the first one. Yeah. Oh, it's just main ops. Okay. Oh, Jesus Christ. Couldn't find a solution. So wonder if it is filling register ESI with 4 unconstrained bytes reference from. Oh, I didn't set ESI. State.regs.esi equals ESI. We'll see if this is workable. So EBP is getting filled with a unconstrained byte, so we might need to, and that's in A5C up here. Yeah, when we first move a thing. Okay, and then EBX at 9BB. Where is that? That wouldn't be in this function, would it? Because it starts at A. So how is it referencing EBP from? Is it calling a function? Oh, it is calling these functions. Okay. And it's using a value of EBP that was not set before. I see. Doesn't really matter, I think, what we may have set EBP to. But we can set it to ESP, or sorry, EBX is what it's using, right? And we'll set EBP first to ESP plus FC plus another C. So 108 hex. But why is it using EBX? And this was on 9BB. Okay, it's just pushing EBX. So we can definitely set that to whatever we need it to be. And we haven't used EBX. Seems like. So we can just start it at 0, because I don't think we are caring about using it. Found something that's interesting. Does it not exit at that point? That's real weird that it wasn't ending, but it had printed flag value. And let's constrain that as well, actually. For b in flag.chop bytes equals, or bits equals 8. Solution.add constraints b greater than or equal to 0 and b less than or equal to 9. Could do that. EBX will just be 0. let's do like, I think it's auto load libraries. So we'll set this to 750,000 and state.regs.evp equals ESP minus or plus 108. It's like auto load libs. And I guess what I could do, oh wow, it's really in the middle of it. Didn't find a solution that time. That's interesting. Maybe I should not set these then. Or those were probably from, no, that's just, okay. Whatever, we'll just do it that way then. See if that additional constraint helps at all. I'm just sort of weirded out by the fact that the like this didn't get printed out until I tried to kill the program, feels like. So yeah, if I interrupt it there, it's still going. Okay. Let's also print yeah. I wonder why setting those registers made it not find a solution. I guess ESI had, or no, do we have ESP references anywhere? There's just so many pieces. Yeah, I don't know. This seems like the right way to go. And I'm gonna give it another couple minutes before I try to kill it. Is there anything else interesting to look at in the meantime? This is another anger course that somebody referenced in the anger Discord. I asked about potentially doing a regular expression kind of like given a bit vector and a regular expression that is like limited in certain ways, could you automatically generate the right constraints so that the bit vector is constrained to match that regular expression? And it sounds like, with a couple of exceptions for things like the asterisk, like clean star thing, it should be possible to do that. Basically, if you can keep it as a fixed length kind of regular expression, then yeah, and that might be a nice little addition to probably add that to Clarify rather than Anger itself, and then you can just use it to add the constraints onto the Anger thing. What did I? Oh. This is what I want to do. Okay. So it's going to take a while yet because I wrote the constraint wrong. I wanted to have two separate parameters, and I told myself that when I was writing it, but I still just threw the and in there. So anyways, when I was in the Slack, somebody mentioned this set of exercises, and it's tied in with this presentation, which there did seem to be some stuff towards the end, auto exploitation, and maybe some of these concepts that I am curious about seeing, what they, I don't know what ACSAC is. It's probably not the college at Sriracha in Thailand. Annual Computer Security Applications Conference. Okay. So, yeah, static analysis comes up with the, you can get a control flow graph and stuff of that nature. It would be nice to see the video associated with this. I wonder if there is one. Reversing challenge with called Wyvern. And just to talk about anger from 4 years ago. And Giovanni doing a talk or a tutorial on it at UCSB. Definitely stuff to read or watch, I guess, in this case. Oh yeah, and I want to figure out what Manticore is. Somebody had a shirt about Manticore. when I was at Recon last year. Introduction to firmware reversing. Probably save that to reversing. Still going. Although it got to the printf, so one would think, but I guess it's doing the solve part right now. I'm assuming the tutorial here, yeah, unrelated to the AC SAC thing. Because I want to know what they were talking about in this slide, you know. Yeah, that seems right. Right. Fuzzing can have some difficulties in that regard. You got an unsat result, so we were not able to find. Oh, okay. Yeah, shit. How do I want to do it then? So I think the issue was we were trying to constrain it to be all digits, but that would mean that all 30 bytes are digits, and we don't necessarily know that to be the case. So why don't we add or b equals 0. So our condition is either b is 0 or it's a digit. And it's still going to take a while to run through everything. It would be nice to be able to save the state when we get to here, and then for me to be able to fix the constraint stuff or whatever, but maybe there's ways of doing that and I just don't know what they are yet. So we'll keep reading through this and we'll come back to it when it has finished. But I feel like if we allow them all to be null bytes or a digit, that should work. I mean, there's a potential that we'll get null bytes in the string when it should have been a digit, and it just happens to also match. If you did like 1 4 7 null 8 6 6 3 whatever, and then all null bytes from then on. And really, the constraint we want is a sequence of null bytes, or sorry, a sequence of digits followed by one or more null bytes. And for whatever reason, where was I at? For whatever reason, that seems like a difficult constraint to add. I think that's you could define that pretty easily with regular expression, but I think that's in the category of regular expressions that you can't necessarily turn into a set of constraints because we don't know the ones that need to be constrained to not be null, the set of those bytes that we want to constrain in that fashion is determined by which one ends up being non-null. And I think you can't have constraints that are dependent on the result of how another thing is constrained in that way. I don't know. It's entirely possible that I am not really understanding well enough the constraint solver or SAT solver kind of thing. And it's perfectly possible to do that, but I'm just gonna hope that we don't get any null bytes in the number when it finishes. Okay, it got there. So, and that took about 3 minutes. It's not too bad actually. And then the solver, how long did the solving actually take? That was only like another 30 seconds. So yeah, we should be in the solution. Okay. There we go. I guess that was the solution. Cool. All right, that turned out to be a lot nicer than what I was worried it would have to be in terms of like simulating the actual process of looping through everything. But we didn't need to worry about it. So let's go ahead and look through the walkthrough, see if they got the same result. Since this is a like reversing challenge and we don't have a way to enter a flag anywhere, we can't be certain that the number that was solved for is the number that was intended. There might be other numbers that fit that algorithm to be considered a success, and they just happen to not be the one that was actually desired by the CDF challenge authors. So 32-bit binary with PIE, prompts for the numbers, and goes into an infinite loop. Yeah. Okay. So I guess all this is doing is creating a string buffer of the flag number, the number that you should be entering next, I suppose. Because I'd say it's only the flag when it actually matches in the check flag function. Oh, and I wonder if... So we were going through 20 times. Yeah, I probably could have drawn some insight that this is a 20 character string, most likely, or 19 characters, I guess, with the null byte at the end. Yeah, okay, so but that's fine. I don't know that that would have simplified anything. Somehow it decided to have an 8 and a 0 here. The end of the string after the null bytes doesn't really impact on anything, I think. I mean, maybe this is not the actual number, and instead we should look for something that's exactly 19 or 20 bytes long. Okay, so oh, yeah, okay, so it is definitely 19 because they got that from the increment flag. Okay. First of our last has a value less than 20 hex. Oh, it's 30 hex as the digits. Okay, yeah, that's what I was messing up when I was looking at that comparison. Okay, so that makes a lot more sense. It's just like if you put in a number, space, something else, or whatever, it's gonna chop that off at the end. Or if it's less than space. So if it's a non-printable character, I guess. Okay. Yeah. So what are they doing? Okay. Okay, that's one way to do it. They find the flag buffer in the address of check flag, and they start at the beginning of check flag. The input must be that. We store the input at the flag buff address. Okay, I see. So rather than sort of come up with a random address, they actually are using the real address based on how the CLE loader decided to base the binary. That seems fine. And that way they can start in like after setting the ESI by calling the thunk stuff. And then they run through with the Explorer, and yeah, basically the same addresses. Not sure about F9A. Is that? There we go. Oh, I see. If you get to the printf, sure. And they do a weird thing to like convert it into a string. I guess because they don't have bytes to print it with, or I don't know. I don't know why they're doing this. Doesn't seem strictly necessary. Maybe because they can't say cast to bytes, and however long ago they did this. It's only 2019, but maybe that's too old. I don't know. And it looks like they were using Python 2 at the time as well. So they got the same number that we got. So that's all good then. I feel okay with that. So we can move on to ROP stuff. There's a category called partial overwrite. Okay, this is probably going to be painful just because it's been at least a week. Maybe it's been 2 weeks. I'm trying to remember. It's been a while since I've done real exploit stuff, I feel like. So we'll see how it goes. Hacklu and stack stuff. create the flag file, and let's look at, and let's deactivate. The line is too long, honestly, but we'll deal with that another time. So, stack stuff, rather. I keep thinking it says hack stuff. It says 64-bit binary, dynamically linked, not stripped. And it's just linked with libc. And NX is enabled, PIE is enabled, no canary, and no rel-row. So we don't have to worry about the canary. And we could maybe use one gadget because we're linked with libc. So let's we're gonna try using the Enger stuff that we have been working with. So /stack stuff, and it said no PIE, pretty sure. Or no, sorry, PIE is enabled. So we could set a base address, but I guess it doesn't really matter. That's just like getting rid of a warning. Okay, then most likely it's going to take some amount of input. Oops. Just from standard in. Like, I'm going to see if I can use Enger to identify where we can start doing our ROP chain without even running the program myself. Just do this, the symbolic execution. And okay. Oh, but I do need to have an understanding of the success and failure cases, I guess. So look at it in radar. Or oh, that worked though. Okay, didn't need to. It's doing stuff with socket. That's not great. Okay. Gets the flag from there and puts interesting. So if we don't pass in aria exec as the first like parameter on the like command line option, then it's gonna open up a socket on I don't know. We'll have to see what socket it opens, or I mean, I guess let's see. So we call socket with 10, 1, and 0. Ten is inet, presumably. Type is maybe stream is 1. You have to like open up the header. And protocol is it gonna mention anything about yeah, so 0 just for whatever like the default is. Or sorry, user include probably. Nope, just include? No. Far? No. I don't know what, oh, it probably tells me what the header is here. In sys socket, okay. I don't have that stuff installed. See if somebody has it on superglobalmegacorp.com. Nice. Stream is 1 and inet is 2. Address family CCITT seems unlikely. But we are passing 10. So, I mean, that's Unix stuff. See what we get in Boolean. inet 6. Okay, that makes a lot more sense. So we try to open up a IPv6 socket, and then we convert 10.0000 and oh, sorry, this is what we are. Okay. 1514. Is that local 22? Somewhere in here. So calling bind with the socket address and the length of the address is that. So I guess first byte is the family, and then maybe the rest of these are these 4 zeros, just being the address, but then we're putting this in the low bytes. I mean, maybe that, presumably that's localhost in IPv6. Then we're going to listen. And it is going to fork what is exec L? Okay, so it's just going to run itself with REXEC. I wonder if this structure is necessary for getting something to be leaked, like to be able to repeatedly run instances of the process, or if this is just like they wrote the socket logic into the program. Because in the CTF context, this is going to be running on a machine that's going to allow folks to connect to it. And usually what they do is they run netcat or something and have netcat execute their binary for every connection that comes in. But maybe they decided they didn't want to do it that way, or they didn't realize they could do that, and so they wrote their own bit of code to do the socket stuff. That's going to be my guess for right now, but maybe we need to take advantage of that fact. Just if we have the binary locally, I can just repeatedly run it myself. Oh, maybe that's... I missed this call earlier because when I was looking through this function at first, I couldn't figure out where we were retrieving input, because we've got a bunch of well, set an alarm, okay, whatever, set buff, fopen, fgets, fwrite, exit, fclose, puts, fopen, fgets, puts. Like, none of this is taking input, but require auth might be doing that. It's going to check if the password is correct, and that calls scanf. Okay. So I think we could still try to use anger if we pass in the REExec argument on the command line. Then I think we can get it to run through all of this logic, not do any of the socket stuff, because I don't know if anger can actually handle that kind of stuff. Args equals stack stuff exec Okay, and then the success case is a certain thing being in standard out. Same for the failure case. So what we want is, the success case is not a certain thing being in standard out, but the failure case is definitely, no, we want to get to a certain location in the binary. So if we've called scanf, we probably want to get to the return in this function. And we might need to fake the stuff for fread in order for that to work. But we want to go to this address. So we'll find that address. Otherwise, we'll get to, oops. We'll get to exit either way if we don't get there. So that's fine. And so if simger.found else raise exception didn't find a solution for it, and I don't care so much about the password, but we do need to set up that file, I suppose. Storage dot, let's look at the Anger docs again. Not sim file system, but storage.file, I guess. Do that. Content is equal to password. And then state.fs. We say dot insert. Or I bet we could just still say Okay, so we'll put in the password file because I believe it's going to read it with the fread. And then let's see. So we first specify a length, then we scan that in. Oh, that's the only thing that we scan in though, I guess. It's just a number. Oh, and then we, sorry, no, and then we fread. So the fread is from the, okay. So I guess we don't need to specify the password file, but we do need to specify the value of real password for the string compare. So okay, it's going to be at that address based from okay, so we'll just read it in from our actual password file, and oops. We want 13. Oh no, I just want to look at the solution they came up with for I can count, because they were doing something rebased adder. Maybe that's what we should do. Just call their project. Okay, so proj.loader.find symbol. Is that right? Yeah. Real password. I'm assuming there's a symbol in there, but I guess we'll find out. Dot rebased adder, and then we can say state.mem dot load password adder password mem. Okay. So how do we want to do about this? Trying to think, trying to remember how we were able to do it with anger and the like exploit ones. we're looking for a situation where we get to that address and I guess I don't want to do explore exactly. Or not explore for that address exactly, like particularly. So if state.regs.rip is this address, but if it's not that address, then we're not at success. And then if state.regs, so the address that we want to return to is going to be state.memory. The opposite of load. Oh, okay. Oh, yeah. So I guess load is this. Maybe I need to call it store. And here we say state.memory state.regs.rsp long. What is yeah, long is 64 bits. Okay. If red adder dot let's look at the practice. Probably 15 has it. If it's, yeah, state.solver.symbolic. So basically, if the memory that RSP points to when we are at the return address is symbolic, then we potentially have control over it. We can try to say get the first solution and we can just throw it on here. So go ahead and throw it there. We'll say state.globals or ret adder equals state.globals ret adder, then ret adder equals 41424344. A, B, C, D, E, F, G, H. Yes. And then so if we just force it to we want solution.add constraints ret adder is equal to that. Then we can say print solution dot sys dot dumps sys dot. I'm guessing file number 1. Let's go ahead and fread rather. So first parameter is the pointer to the buffer, then a size is the second parameter. Oh, and then how many, and then the last parameter is, so it is reading from standard in. Okay, cool. Yeah. Then we can give it a shot. Of course, I need to be in the VM. Store takes 2 arguments. Three were given? What? I only gave 2 arguments. Let me double check that I am not. Or just like state.memory.store. Okay. I guess we have to do that version of it. On which line? Oh, yeah. There was something in the documentation about this. It's under solver engine. Is true. Okay. So it's doing a search. I don't give myself very good odds that we find a solution, though. But the idea is, if we do hit that return and the address is symbolic, then we'll go ahead and constrain it to equal a certain thing, and then we'll print out the input and we can look for that certain thing, and that should tell us where in our input we need to start writing the return address. What did I do here? But the other thing that I could certainly look for is the fact that we are at RSP plus 10. That's interesting. We've already subtracted 58. Wait. We're going to read to RSP plus, oh, sorry, 10 hex. Yeah. Okay, so then in theory we need to write 48 hex bytes plus another 8 bytes. So 50 hex bytes, and we can control the value of the return pointer. And it's just going to do the compare and return from that. So yeah. I mean, maybe anger just doesn't, or I don't know how to use it well enough to really help myself for this challenge. But why don't we just go back to the original set of tricks? Because I don't know if anger is really going to help in this way, in this case. So we need the number that we have scanned in to be I'm a little confused on this comparison jump. If that number is so JLE right, what is the result of calling test? Bitwise logical AND of the first operand and the second operand and sets SF. Okay. So zero flag is going to be set if EAX was 0. And JLE is if zero flag is set or sign flag does not equal overflow flag. I don't know how and sets the sign flag. So OF is cleared. Does it not mention how sign flag would be set? I guess sign flag is just if the upper bit is 1. So if we actually gave a negative number, I guess is what they're saying. Okay, so yeah. If we gave 0 or a negative number, we come down here and we're actually going to set a length of 5a, which is that that is enough for us to get a couple of return values in. Otherwise, yeah, or we set a number that is greater than 50. Seems like it's kind of a weird set of circumstances. What the hell is going on with this? I'm gonna just kill okay, I guess it did die. Okay. I don't think that was very helpful actually to use anger. I mean, it was nice to think about how I should try to find the like location in memory where we would start putting the return addresses, but it doesn't seem actually like I can make use of that. Or I guess I don't know how to do it, is maybe the better way to say it. So we're going to go the traditional route. Import everything from Pwn Tools. And stack stuff is our binary. Then we want to run the program. Is that not right? Maybe it's just no, it's not regexec. Re-exec. Do I need to call it? So let's see how this is working. Yeah, so we are getting okay. Just has to, it can't be /reexec. So the first thing we need to do is set the length of the password. And if we say like 55, and then let's just do it with how do we actually, I wonder if we can force that. Like force the first parameter when we run it with Bone Tools. Should not include argv0, even though we definitely wanted to override that. Okay, it's fine. Uses argv0. Okay. So if we say we can use the binary later, but target is going to be like process argv is reexec and I want a times 0x 48 plus b times 8 and then cvol oh, I need to deactivate I need to maybe set the path again. Starting, oh god damn it. Is it really still? Let's get this whole thing, and then we'll put the current directory and just double check. Okay, so then Python hacklu exploit. Yeah, of course. deal with that in a minute when we need to. Broken pipe from the send line, where line 8. Well, first let's do unable to read real. Oh, okay. Versus if we go into and then run it that way. Yeah. Or wait. How was it looking earlier? Oh, okay, it works fine if we do it this way then. Is that not long enough then? 48 hex. Let's pass in a negative number. Okay, so then let's say payload equals that, and we want to send payload plus C times 5A minus. Okay, now we've got our sig fault, and where did we end up? IP was that nonsense? That's a little confusing. We're in here, and okay, that's us controlling EIP. I don't know why the 8Bs was not just showing up in EIP. So, man, I just fell out of practice on this. We want to do the one gadget if we can. But we also might just be like do a gadget to read flag or something. But yeah, let's try and return to this address and see what that does for us. Just make it interactive after that. But it is PIE, so we need to be able to leak. Oh, yeah, we need to do this function multiple times, but we don't know where. We don't know where libc is, and we don't know where the rel, like the GOT, is either. Don't really know where anything is. We need it to leak an address somehow. I'm assuming, I mean, you know, maybe your design is supposed to be to brute force the password, but it doesn't seem like that would make any sense, and it's not, wouldn't categorize this as ROP if that were the case. So what is an address that we could know? So it is possible that this is why the socket stuff comes into play. If we need to run through the code once in order to get it to leak something, I just don't know how we can get it to leak something still. Still not sure on that. But potentially, because we're just doing fork, some of this memory is going to be shared, I think. I guess technically it's forking a child that then calls exec on the binary that we are. So maybe that doesn't make sense. So exec is going to be a separate binary or a separate task with none of the shared memory or anything, I think. Yeah, how do we leak something? Let me double check. Yeah, we have PIE enabled, so oh, is my stream still working? I didn't notice that it's been showing the same thing to me the whole time. Okay, no, it's been updating. Yeah, that's unless the alarm situation, it has like a handler for it or something, but I didn't see anywhere that it set up the handler. But if it does do that, yeah, it's not its own function. What do we want to do? We haven't opened the flag file yet, so it's not even in memory. Can we just write a success? I guess we don't need to necessarily return. That wouldn't make this a ROP thing, but if we can, oops, I'm going the wrong direction. If we can set what EAX gets set from, perhaps, but yeah, it just pulls whatever str compare has. So other than, well, let's think about this. Okay, so maybe what we need to do is return from this function because it's just going to use I see, yeah. We still don't know where we would return to, honestly. Maybe. Okay, maybe this is simpler than I'm thinking. So when we have control over the value at RSP and we are doing return, the value at RSP is going to be something with this as the low 3 bytes. Just whatever, however it's based. And if we go ahead and set, but the issue might be, okay, but just to continue with the theory, if we set instead of 1, we set 5, for example, then we're gonna end up returning from this function. We're not gonna get into the loop of bad whatever, which would only require us to set the low byte in there. The problem is that I was thinking about is this length situation. If we provide a number and it is less than 0 or a negative number, we're going to try to f-read 5a bytes, which is too many past the point at which we are writing over the return pointer. Because we're starting at RSP plus 10 and at RSP plus 58 hex is where we start overwriting the return pointer. And so 5a is going to require us to write enough bytes to overwrite the whole return pointer. Whereas 32 hex is too short. So we can either write too little and not be able to impact what we need to impact, or we can write too much and then we don't know what to write at that point. So difficult. Right, we don't have any pushes or anything. We're not modifying RSP through all of this. Adding 2 to RDX. What are we using RDX for? Yeah, still don't know what we use RDX for. So yeah, we really need 72 bytes written. And we can either write 50 bytes or 90 bytes. Unless, how does fread stop? Maybe I'm, what to send to the program. Maybe we don't need what is it? Okay. So Python print a times 48 plus d9 end is empty string. Okay, so we have, why is it 99 C3? Jesus Christ. I don't think this would matter. Oh, of course I needed to, yeah. I can just do sys.write, I think. Is it? Can you friggin' show me? Oh, Jesus Christ. And this is Python 2, thanks. .buffer.write. Okay. Cool. So then that's 49 bytes. Right. Okay, yeah. So, oh, and we need to, I guess, no, interesting. So I thought because this will be the end of the input, there's going to be catted out, right? Yeah, it's going to do that. It's a little weird that the 1 byte turns into a couple stuff there, but oh, it's called partial overwrite. So yeah, I mean, this is definitely the approach that we need to take. But maybe my stack math is incorrect. So we should be able to just send that and all right, so continue. Oh, because I didn't put any breakpoints in, huh? Oh, did that work? No, that doesn't make any sense why that would work. Yeah, I didn't think so. Okay. It's still waiting on the... Does that make sense? Yeah, it's still... Oh, right, if we run it, attach 6952, and then continue, so that's the read from scanf, and then we continue and we hit Control C, Now we're in the F read, so it's still waiting in F read. We've read in a whole bunch, but not as much as we are supposed to be reading in, I suppose. So can I close something in the process, like close the standard in for it? What is process.proc? Doesn't say. Well, let's look at this. It's a buffered writer. Can we close that? Yeah. Okay, let's give that a shot. Okay, well that finished at least. And then we want to disassemble, what was the check password correct? So after the call to fread, okay, so we have done the call to fread, and why did we get there? Oops. Oh, Jesus Christ. There we go. So the amount that we read is not, oh, I missed that bit. Okay. Yeah, so we're going to compare how much we read with how much we said we were going to read in. That is definitely a problem, because I feel like if we have to read in either 50 bytes or 90 bytes, then I don't know. I don't know how to do this. There's really nothing else for us to be overwriting. Oh, am I just reading this wrong? I think I am. Jesus Christ. Okay. So, no, I'm not reading it wrong. For a second, I was like, is this simpler than I thought? Right. So if the value is less than 50, or less than or equal to 50, then we'll use it. Otherwise, we'll do 90. I mean, we could try a length of 50, but I don't think that's going to overflow anything. Let's just do it that way, and then we'll just say 50 here. All right, so we read in 50. And we go to the string compare, which we don't care about. It's going to fail. Although yeah, we're just using AL, so yeah. Okay, now what's that RSP? It's just the normal return. Jump equal. Then I'm going to call back to check password correct. Yeah. So how to scan in a number, like, or get f read. Oh, and I closed. That was not necessary at that point, but right. So if we actually put in the amount we want, which is 49 hex, so just 73. I assume that is going to be upgraded. What? Yeah, it's not sending enough. Okay, so we did that much. And now RSP is all those B's and T9 in the low byte. Yeah. So I got nothing right now. I really don't have a clue how I can get that low byte overridden without also needing to overwrite the rest of them. And if we knew what we could overwrite in the rest of them, then I think, we could do a lot of stuff. That would, we would need some kind of leak to have that information. So, it is not apparent to me how to leak that information. Yeah, I just still can't think of anything. And then presumably get the sig fault. Yep. I don't know. I think I'm just going to read the walkthrough on this one. Do this by bypass PIE's address randomization. They will brute force it. Okay, I had this thought just a second ago of like, well, you could just try your luck and maybe what you come up with in the high set of bytes. I mean, you know, almost certainly it's going to be starting with this, and so you're really just randomly trying maybe this chunk. Let's see what it looks like when we just do 50. Okay, so we get to the ret, and it's maybe this chunk. Like this was our address. Oops. Okay, and this time it's this address. So it really is three and a half bytes that might be different, which gives us, you know, some number of millions. That kind of brute forcing seems like too much, I feel like, for, like, I don't know, it doesn't seem like you would want to have an exploit that only works 1/3 millionth of the time or something. 2 to the power of 24, 28 is 268 million. Yeah, so like 1 in 268 million is not a good rate of success. So they must be doing something else to reduce that, even if they're doing some amount of brute forcing. Like it's this is where vsyscalls come in handy. Okay, so I'm going to try to avoid reading the entire walkthrough, but at the same time I've spent a good chunk of time on this one, and I'm towards the end of when I want to end streaming, basically. But what they're saying is their way of getting around PIE being enabled is, and there being no leaks, that the virtual syscalls thing, the VDSO thing, I guess is maybe at a fixed address. I really thought, oh no, VDSO is at a non-fixed address, but the older vsyscalls is at a fixed address every time, I guess. I mean, that's the same address on as what they had in their thing, whereas this is probably not the same address. They had 7FD1, and we have 7F74B and stuff. So, yeah, their VDSO, not the same. And I don't know what VVAR is. Maybe that's related to VDSO, but it's just the read-only portion of it. But vsyscall, the virtual syscall thing, is at a fixed address, which is, I remember reading, because I was, at one point I was like, what is VDSO? Why is that in there? And so in the article on, what is that Linux? Let's see if we can just find it. No, I mean, I must have looked at that Stack Overflow thing, but oh, and maybe they link it from here. Yeah, LWN, right? The like Linux sort of kernel newsletter, I guess. A lot of stuff by Jonathan Corbett. So in here they talk about why VDSO is a thing and the sort of the discussions around that, and especially the argument that Linus had with the dude that does, or maybe multiple people that do the version of the Linux kernel with tons of security patches. Try to remember the name of it right now. Yeah, PAX. So they wanted to make it very clear in the kernel config that the old vsyscall is a bad thing to have, and they wanted to call it unsafe. And Linus was like, well, you know, you're sort of putting a value judgment or whatever on that implementation as unsafe, and since it's a politicized name and all that. Anyways, I thought that was interesting, but it's not really relevant to the details of, I mean, in this case, it's the thing that apparently is going to allow us to achieve what we need to. And I think if we can find a gadget in the vsyscall area, then what we will have is we'll overwrite the return address with that. Then we will overwrite this, and so that's another 8. So at the beginning of this is 49. So up through here is to 50. So this is 51. Up through here is to 58. We have 59 and 5A. So we have to write the low. I see. So we have to write the low 2 bytes of the address, but it's only the low 3 nibbles that define, that are like not determined by the page, or that are within the page, basically, in the 4 kilobyte page. So we want to write FDI here. But we don't necessarily know what to put in that high nibble, which gives us 16 options. So that's much more reasonable to brute force, right? Or we want to put FD9 rather, but we don't know what needs to go here on any given run. So a 1 in 16 chance seems like enough. But I'm going to leave that to the beginning of maybe, I don't know, let me look at, see what ROP gadget gives us. ROP gadget. Is there any flag to say look at that, or can we just say I guess we can try to find out if the ROP gadget code will find stuff in the vsyscall section. Binary is gonna be did not find any there. I guess vsyscall is really just mapped in from the kernel, so it's not actually in the binary. And we don't really, I don't think we need the syscall stuff, because I mean what I ended up reading in the Nightmare Challenge, oh interesting that shows up, but what I ended up reading in the walkthrough was, let me just close some of these, ended up reading that they were just trying to find a gadget that returned. I think what we need is something that's gonna like pop and then return, because, or maybe, yeah, it needs to pop because the order of increasing addresses. So we'll return, then ESP will point there, and we will need to pop to get that address. Yeah. And I guess technically we wouldn't even need to write the, yeah. We don't want to, we want to write this address again, but you know, we're still stuck with the, like, we need to figure out what that high nibble of the lowest 2 bytes are. But this can be the address that we write 08B, because we want to just return back into handle request. But we need to get rid of this value in the meantime, because if we return, then it'll try to return to this, and well, I mean, we could write it twice, I guess. That's true. So if it's just a return statement in vsyscall, why don't we look for what is it? Yeah. So we want find, and we want a, what is the ret? C3 byte. So find /b from here to plus 1000 C3. Okay, so we found one at that address. So let's see if we can just use that address twice. Okay. And then it's going to be 08008B. And we'll just do this while true with, let's see, pwn dot local. Oh, what is it called? Local config or something, or maybe it's pwn dot config context dot local. Oh, context. Okay, with context dot local. There we go. Log level equals error. Okay. So we have a base payload, and we are going to send -1. We're going to send payload base plus B. Yeah, we'll do P16 of handle requests adder plus. I guess maybe we'll just try our luck with it being 0. So in this case we got an F, but I think if we were to run it again we would get something other than F. We don't care about EOF issues, I guess. Oh, right. So gonna say receive line 3 lines. And where are we stuck? Trying to receive. We get 1, 2, 3. Oh, I'll just receive until the prompt. Alright, this time we were waiting forever on receive all. So let's go ahead and take out the pause. Okay. So we're going to return to the return. Oh, we don't need to. Do we need to return it 2 different returns? No. It did get a segfault from that. Need to change that to just be the here. Okay, now handle request, was it? Yeah. So that after require auth is at 30B. 30, wait. Yeah, so we just wrong on that one this time. But it should be otherwise should be right, the right code. So we just have a certain chance, I think. Let's double check. Oh, okay, and this time we're at 7008B. And there's the 7E08B. Yeah, okay. So I'm gonna I mean, I thought we would have a 1 in 16 chance, which should be a lot better than this. maybe it's never 0 for some reason. I'm going to put 3 in there because we saw that once. Let's not pause anymore. Let's go back to error. And oops. It's quite surprising that we aren't seeing it at all. Unless something is a receive all should work. Well, let's go ahead and put info in here, and we'll get the spam. But is it ever succeeding? It must be succeeding and my check is not right. I do want the break actually. Nope. So if we got the seg fault, that doesn't cause yeah, it's not actually succeeding for some reason. What the heck? 5593 5593 E607 and then just off one. Misaligned v syscall. Oh. Maybe it has nothing to do with using that as a return. It's possible that this is another protection that we didn't. What is misaligned v syscall about? Like maybe they didn't have this protection on whatever system that they were using, it's 2015 Hacklu, so maybe. vsyscall number less than 0. I see. So this stuff, which, you know, I'm pretty curious when this got added. 4.14 should be pretty long ago, I think. We were in Arch x86 entry vsyscall. vsyscall 64. When did this stuff show up in the kernel? 9 years ago. Okay, so they're most likely handling this because 2015, you know, is recent enough. So that just means we need it to actually be a real syscall, I guess. So it needs to and with it's not a 3. So let's see. If bits like 10 and 11, starting from the lowest valued bit, if those, how would that be greater than, oh, so if it's not, wait, what? But that's not true in my case, right? So there's only 3 numbers that are allowed, or 0, 1, and 2 are the only. Because where did we find it? something I'm misunderstanding about this, like what the requirements are here. And how are we even getting into emulate syscall? Because we are purely trying to jump to that address. So let's put the pause back in there. Okay, so we're going to try to return to this address in the vsyscall area. So now we're at that address, and it is also a return instruction. So we are going to return, which is to that address again, and why is the second return a problem? All right, what does okay, fair enough. It's going to be an add. That doesn't help me at all. I guess it doesn't hurt, but it definitely doesn't help. And or it does a syscall right before then. Okay, that doesn't help at all for sure. Yeah. So if we have single ret after the syscall, right, we could do, that's just null byte. Yeah, it's just a gadget to do a syscall, but I don't want to do a syscall. So we can do the return, but why does the return cause problems? Apologies for that noise. Why does returning twice like that cause issues? I don't know. I feel like reading the walkthrough again. They found other gadgets, I guess. Or Oh, okay, yeah. He initially tried to jump straight to a ret instruction, however, it would crash after the second gadget. Um, so I don't know how that logic is getting triggered with the emulate syscall, but I guess returning from the vsyscall area somehow is disallowed. Well, let's see what gadget they identified. Oh, I mean, yeah, we can just look up vsyscall addresses, I guess. So they have I see. So we'll write into one of these registers. Um, so I guess that's how the vsyscall operation works. Is like you jump to effectively or call to a certain address within that space, and when it returns, it somehow gets trapped by the kernel. Um, and then it checks based on the address that you jump to what syscall number to go to, and that's when we're getting the issue. So returning within that segment is a problem basically, unless we are at one of the approved addresses. So where was yeah, it feels like we should be able to search for more stuff with the find. But it's still just finding the one, which I think is interesting. But it's not plus 1,000 is probably the thing, right? It is plus 1,000. Right? So, what the heck? 0x1000? There we go. Okay. So, we could do 409, but we probably don't want to return directly to the... Right. But if we look at ret... but I mean, I guess it's fine to do the syscall if we go to the beginning of it. And I don't know what syscall it's doing, but let's give that a shot. Okay. Did not understand the mechanics involved. That took one try? Yeah. Okay. There we go. Second time it took 14 tries. So it wasn't random, but, or I mean, it was random, but we just got super lucky on that first one. Cool. That, you know, I had heard about the vsyscall thing, and it made sense. Like, oh, if you have a fixed set of addresses for stuff, that can be exploited. And it's one of, it felt like one of those ones where, oh, okay, it, in theory, anything like that is a security vulnerability. Whether or not it's actually going to get used in an exploit or not is a separate question from whether it should be fixed, because it does represent a bug of security issues. So okay, this was an interesting one. I don't feel great that I had to resort to looking at the walkthrough, which sort of pointed me in the direction of what I needed to do, but sometimes that's how it goes. I don't think I would have, certainly I wouldn't have thought about the vsyscall. I hadn't even looked at the VM map. This was like completely out of where I was potentially thinking. I got to the point where I couldn't think of anything left. But yeah, I guess I'll have to keep that in my, set of things to consider at some point. It just feels like probably vsyscall doesn't get mapped in modern binaries anymore, and VDSO is designed to not have this issue, and it gets mapped, randomly if ASLR is on. So cool. And then obviously the other difficulty was just understanding how the VDSO region worked. They went with this syscall, but the 400 one is also fine, and I guess maybe we could have done the 0. Yeah, okay, that makes sense. The 0, 4, 8 are 0, 1, or 2 bits in that area, and there's only 3 syscalls that it supported. So maybe if we jumped to the very beginning of that range, it would have been fine. I don't know. What do they do? While flag equals 0. They go through and all that stuff. So cool. Then, oh, they do theirs like actually connecting to the process and all of that. And I sort of sidestepped that by making us do the re-exec variety of it. Well, that's everything for this stream. Oh, I missed Errol Gurry. Thank you for the follow like half an hour ago. Hope that some people have enjoyed watching me get back to struggling with binary exploits rather than just using anger to do reversing challenges and stuff. I'll keep up with this. We've got a lot more in the another 1, 2, 3, 7, 11, 13, 16 roughly. So another chunk, I guess there's 15 left now in this group of challenges, and then we can move on to heap exploitation. We're finally getting there. So yeah, I will be back to this on Monday, and in the meantime, over the weekend, I'm going to do a stream on Saturday and a stream on Sunday where I go with more Try Hack Me rooms. I started on that last weekend, and it was going reasonably well, so just going to keep up with it and see how far I can get, see if I can learn more about web exploitation stuff as well. Thanks for watching, and I'll see you at the next stream.